fascinating. Really fascinating. In fact, the most fascinating thing I've ever heard.
Alright, time for another DraftPhysics.com, debatephysics.com. Also, video presentation. Two morons, frankly. That's what the audience is. Who? And they'll be convinced by what? It's just this going around and around nonsense. When I've provided a reasonable explanation for how particles, or a corpuscle theory can explain the double slit experiment beautifully, frankly, and explain the distinctions between waves in a medium, and the fact that you can just have events at a period, and the whole tipping point thing, it all fits very well. And then I've also explained that there's this fundamental part of physics. I mean, it's just one of the most elemental functions is the interactions between electrons and protons. The fact that electrons hate electrons and protons hate protons, but protons love electrons and vice versa. So you have this push-pull thing, attraction, repulsion, and their explanation physics, conventional physics, has nothing. They just tell you that's the way it works. Frankly, I mean, they have some idea of a gluon, which is something that bangs into something and makes it go in the direction it came from. So is there anything more gremlin-like or pixie or hobgoblin? I mean, could you make up something more? Dark matter, you could make that up. I mean, come on. I mean, their physics is terrible. It's nonsense. It's crap as an explanation. It's a shitty theory. And then I have to sit there and, do this minutia with these morons. It's just pathetic. You're not trying to understand. Regular physics demands that you do all this rigorous math. You do equation after equation after equation. You do all this integrals and blah, 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 blah. I'm not asking you to do any of that. I mean, you could just draw it a little bit, a couple little round objects. I'm not asking you to do much at all. And you can't handle it. All right. Anyway, so Elizabeth, quite sick of you. What I do not understand about your nucleus theory. It's a theory about electrons and protons. The fact that it forms nucleuses, is not the theory. Is if it is supposed there is a electron between protons, why the other electrons surrounding it are not captured or by those same protons? Well, they are, moron. Anyway, and they keep surrounding the nucleus, for example, in hydrogen atom. Well, hydrogen atom, for example, is a really shitty example, frankly. Because basically a hydrogen atom is pretty much, a neutron, but in larger size. Not as tightly packed, you could argue. I mean, it doesn't really have a neutron in it. It is a neutron. Also, why is the nucleus positive if there are electrons between protons? Well, just do the math. 2 protons on either side of an electron. So there's 1 electron and 2 protons. You can't understand that would end up being a net positive? All right, the charge must be canceled. Well, how exactly would it be canceled? There's twice as many protons as there are electrons. So, I mean, it's just, you're not even trying, And the other moron's comment was something like this simple, it's connected to the subject. So I'm just going to go over the charge explanation one more time. I've already done it, been there, done this. I've got to do it over and over and over again for no damn good reason. Not because, it's so horribly complicated. No, not because it's so much better than no theory from the other assholes. No. Just because you people just couldn't care less about getting a reasonable answer, and all you want is, you want something more fabulistic. You want something silly and complicated. So the simple phenomenon is that the protons, let's call the red things protons, positive, okay, and negative, north-south, you could argue. These are the monopoles of magnetism, by the way. It's just so obvious, electrons and protons. They create dipoles. As soon as you have a dipole, so as soon as you have this, okay, you have an electron and a proton very, very close together and even bound to each other, that is, now they'll rotate, that's called a magnet, okay, because it will orient itself to a field based on the tension between electrons and protons. So anyway, what you have to account for is this idea, okay, that, okay, the protons hate the protons, the electrons, we'll put another electron up here. Is this the green? I think that's the green. All right. And obviously they repel each other. And then there's attraction, so I guess we'll draw that like this or something, I don't know. Okay, between protons and electrons. So it's a pretty simple thing that you have to explain. I mean, they're exact opposite effects. And physics can't do it. They can't give you an explanation for why this phenomenon exists. All right, nothing. They have no explanation. Nothing. Zero. There's no explanation, really. There's nothing. Okay, nothing. All right, my simple argument is the universe is, as you would might imagine, there's a bunch of energy in the universe, okay, that we can't see, okay? Yeah. So that's not hard to understand, right? And that energy has the same disposition as this electron and proton. That is, it comes in two types, okay? So there's electron force and there's proton force. And it's all flying through the universe. And when you give it a frequency, yes, it does something different. When you give it a pattern, okay, then it's going to be, it's going to have a different effect on things in the universe. And the simple fact is that for the proton, okay, the only thing that can hit it and move it is a red force. That is a proton force. So if a proton force hits it, it sticks to it. Okay, let's say it wasn't moving. It sticks to it. Okay, it stays right there. And the object, the total object now moves in the direction of that thing it collected. But it obviously, the proton's a lot heavier than the force, so it goes maybe 3% of the speed of light. Okay, it goes much slower than the speed of light. Or it might be 10%, who knows. One bit of force moving one proton will cause momentum of the larger object, and the speed will be greatly reduced. All right. And the fact is that a second one could hit. It's moving the speed of light. This thing's only moving 3% of the speed of light. Obviously, it's going to hit it again. It could stick, and it could add up a bunch of force going in one direction. And you wouldn't call that, a high energy proton or a high energy electron. Okay, it would be one moving very fast, and it's moving very fast because it's collected a bunch of energy going in one direction. Now, if it hits opposing energy, that is, say a piece of force comes this way, more force this way than it's going this way, obviously, then what's going to happen is this force is going to reflect. Okay, it's going to hit because it's moving this way, it's going to reflect, and this will lose one of its pieces. All right, and those will go off in opposite directions. So there's always you can only go in one direction in one dimension. So there's 6 subdimensions, you could argue. Okay, up, down, left, right, forward, back. You can only go forward or back. You can only go up or down. You can go left or right, but you can't go both. Okay, obviously. And so obviously if there's more force coming from one direction than another direction, the matter, the proton, will move in that direction. Now, if a green force hits, all right, it does nothing. Okay, it goes right in, and guess what? But the trick is it comes out a red force. So a green piece of force hits, and it pops out red. So that's it. All right, so those are the two interactions, basically. Okay, basically either you get momentum, reflection, or it just passes straight through and just changes to the color you are. Now that will, okay, in fact, create exactly what Maxwell drew as charge, okay, in the sense that you have two bodies that are radiating opposite. Now, they drew it as arrows going out, okay, and arrows going in, okay, that's how Maxwell drew it. But I mean, really, you're just saying, oh, they're two radiators, okay, but what are they really radiating? They're just radiating a reflection of the universe that hits them. That's the simple explanation. And when you move them, they're not going to radiate because they're collecting the force when they're moving. You could say obviously. So instead of one being an in and one being an out, it's just, you're basically just saying, no, one's a positive, one's a negative, one's a north, one's a south, and they're interacting, okay, with two different forces. So one is radiating electrons, right? Because every piece of red force that goes in comes out green, right? So every piece of red that goes into it comes out green. And then we know every green force that hits either moves it or reflects. So we know that means that all the green force is also reflecting a lot, okay? It's also moving the object, but it reflects a lot. So the movement would be an absence of an arrow. And the proton will do exactly the opposite. So what you'll have is a drawing of two perfect radiators. The protons will create this red force. The electrons will create the green. And the fact is they are inert to each other in the sense that if the red force hits the green, it's not going to do anything. If the green force hits the red, it's not going to do anything, right? So it's going to pass through and change color. So there is no pressure, right? There's just no pressure possible between the two. I mean, I can't take a red force and hit the green with it, right? And I can't take a green force and hit the green with it, right? Because the green force will be turned into a red force can't hit it. A red force can't hit it because it's red. The green force can't hit it because it gets turned by the proton into a proton force, and then it goes right through the... So you know there's no pressure here, and you know the external universe is still acting out here. So obviously that would push green things into red things. You could understand no way to avoid it. It's a huge... there's just no way to avoid it, right? There's just no way to create any pressure between these two because there's no mechanism to create the pressure. In the opposite case, that is where a red is interacting with a red, well, there's a ton of pressure now because every single green that comes in is going to be converted into a red. So all the external force that has, green in it, okay, all the green bits that might be coming towards, going through these two towards each other, right, all get turned into reds. And we know that each piece of red force is really a piece of momentum moving in the opposite away from directions. So obviously there'd be an awful lot of push here and an awful lot of push here. Plus, the very fact that any red that's between them is just going to keep bouncing back and forth unless the two objects are going away from them. And if they're going away, then it's going to collect it. So if the proton's moving towards the proton, it's going to reflect, which means it's going to just keep reflecting back and forth. And if they're moving away from each other, they're just going to collect, which means they're going to go faster and faster. So obviously this is very high pressure here, okay? And there's lots of reason why the two things would fly apart. So that simple explanation explains push and pull between electrons and protons. It explains all the relationships you have between electrons and protons. This simple mechanism. All right. So we need more paper. Now we'll just do this. Okay. So nucleus formation. So we know there's only a few, less than 100 configurations of nucleuses. All right. So I start with, let's say, the electron. And we say that, okay, it attracts a proton. All right. And now we have what's called a neutron. Now, the trick is that in the free universe, these two things, okay, even though they're bound to each other, they're getting hit by the universe in all kinds of directions. That is, directions that could cause tension between them. So let's say a force is heading this way, a green force, and a red force is heading this way. You can understand that it's going to push this one this way, and it's going to push this one that way, and it's going to be opposite ways. And I could have the tension going the other way. So it's like you're pushing on a wheel one way, and then you push on the wheel in the opposite direction, and it puts a bunch of torsion or stress on this bond. Okay, the part where they're attracted to each other, connected to each other. So they will, you could say that in free space, when they're going to get hit by a bunch of random force, randomized, that there could be circumstances where that configuration is hitting them at this 1 second of time. This one moment of time, there's more force coming one way than there is coming the other way, and creates a stress that pushes them further apart. So in free space, they wouldn't be as close to each other. And you could argue, though, in a nucleus, okay, when they're in the sun getting formed, that everything's being pressurized. So there's a ton of pressure pushing everything together, very high pressure. So they get smashed right up next to each other. Now, how that actually looks, what actually happens to them, when they squish together, they could actually just turn into a capsule, where this half was the proton and this half is the, and the other half is the electron. It could be something like that. And so that would be inside the nucleus. And so what you have is the electron here. All right. And the proton here, and that's your neutron. All right. The basic form. And then when they're under high pressure, all you got to do is smash another proton onto here, right? Okay, so now you have a proton on this other side, and so on and so forth. And the idea is that, if I kept doing this, and I could add electrons here, okay, I could add electrons here, I could keep doing this configuration, but the simple truth is that we know that the protons are always in the nucleus, and the electrons are on the outside, and we do have some indication that protons are heavier than electrons, and so they're harder to move. So the argument would be in nucleuses, okay, the protons are stuck in the nucleus because they are harder to move. And the simple fact is that you could imagine an arrangement where you have twice as many protons as you have electrons, okay, in terms of the geometry, and that the electrons would have been on the outside. And the fact is they're on this is the noisy part. The outside of the atom is the noisy part. The inside has a lot of pressure, but it's all pressure in one orientation. Out here in the real universe, there's energy moving in all kinds of tangential directions, and you could understand that the electrons get pulled off of the nucleus. So it would have had the same number of electrons and protons, but because the electrons end up on the outside, they end up getting pushed further out. All right. So once you have a nucleus, though, right? So you know that only a number of these nucleuses can survive. And obviously, I'd say it's a dimensional thing. Okay, you start with you could understand that there could be, the up downs, the left rights, and then you could say the forward backs, where you have electrons that are doing the forward back thing. So you have, again, the 3 dimensions that they could exist in. And then you could understand that once you put, once you have a nucleus, then the nucleus was going to be positive. So I should draw that differently. Yeah, I really used up all my paper quickly. Anyway, so you have the net positive nucleus. All right. And so you can understand that, yes, the electrons, but the net positive nucleus has places where there's electrons that are visible to the external world. And it's just that you have twice as many protons as you have electrons. So you have twice as many little red things as you do green things, but there are places the green things can be seen. So obviously an electron, let's say if an electron was going to show up, it wouldn't show up here because there's an electron there it can see. It would show up here between the 2 electrons. All right, so it'd be attracted, but it couldn't get too close to these electrons inside the nucleus. So you understand why these free electrons don't go and stick to anything. And to make them stick, to create a isotope, you need to put in a lot of energy sometimes. A lot of energy to force another electron in, or to force a proton in, would require all this extra energy, because you have to overcome the resistive forces that exist before you get really close. So the idea is that if I drew an electron and a proton and an electron, you're going to understand that if I got really, really close with another electron, that is, if I could get it in here really quick, it could sit right here and it wouldn't be as much tension. But out here, it can see these electrons. Okay. So you could make one stick if you can get inside, really, hit it with a lot of energy, get it into that proton, then you can overcome this resistive force. Okay. But you can't really do that, I mean, these wouldn't be in alignment, actually. This proton would probably be back here, and the two electrons would be out further, and so you could understand that you could push the electron the electron all the way in that proton. Then, okay, so I'll make it red. You could you get past this force, you could understand that, yeah, it's just a matter of measuring how much pressure there is against it. And once you're here, the electron would stay here, because now the pressure is going to be pushing it in rather than pushing it out. That kind of thing. So it's all just about geometry. So just understand there's only 100 of these things that can work, 100 places you can put these little objects. Okay, that's why there's orbitals, is because merely the electrons all don't like each other on the outside, so they have to find the position. If there's two electrons here and here, the next electron has to sit here, and then the next one will be out here. So they always have to orient each other so that they're far away from all the other electrons as they can be, and as close to the protons as they can be. And that's the balance and the tension. So there's a real theory, okay? It's a real mechanism, not even very complicated at all. I mean, all you really have to accept is that there's two kinds of force, all right? Two varieties, let's say, because they're so similar, and their only difference is the one moves electrons and one doesn't. One moves protons. That's the difference. They interact in two different ways. And so that's really not that hard to figure out. And not even to figure out, but to accept as a reality, versus a gluon, which, hits it and makes it go in the direction it came from, right? Which is silly. All right. A reverse-eron, they're nonsense theory. All right, so anyway, I've probably done this better in previous videos, but it's just so fucking simple, and you're telling me you can't understand. Well, then you're too stupid. There, sorry, you're just too fucking stupid. I'll pause and see if I need to say anything else. But this is ridiculous, all right? Explain how this simple mechanism doesn't produce what Maxwell drew, which is two radiators, okay? That one radiating out, one radiating in, and the only change I'm making is no, they're not really radiating in and out. They're radiating to subtly different, blue light versus green light or something. They're radiating two different things, and those different things are opposite to the two elements. The electron sees the electron force as a motivate, something that'll push it, and it sees the proton force as inert. Okay, it doesn't do anything to the electron, and the electron does something to the force itself. It changes it. Anyway, not complicated. All right, so the simple argument I'll make is let's say we're doing a Rubik's Cube, and I mixed it all up, and there's a shortest path that is the shortest number of moves to solve it. And the fact is that this solves charge in the shortest number of moves. I'm going to say that they'll never come up with a way, a mechanism, a mechanical device that can get you to what charge does simpler than this. There's no simpler way. You can't make it one force. You can't do this. Now, there's no simpler way to make the two electrons and protons have these distinctively opposite features than to simply create two kinds of force and two kinds of matter and have the two kinds of interaction. That is, the passive interaction where the force is merely changed, and the active interaction where it's either given momentum or there's a reflection. That simple mechanism is going to be the simplest answer. There won't be some simpler one that it could be ever made up. And the fact is it works. Nature's using that simple mechanism. That's the simple mechanism that causes the effect of charge. It fits. It works. And it's so damn simple. And you people suck. And that's pretty much proven, okay? In the sense that you're just going to keep defending a garbage theory that has no mechanism. Bent geodesics, dark matter, gluons. I mean, just invent pixies. You might as well just call it hobgoblins and the rest of it, because that's all it is. It's just voodoo. It's not real physics. It's voodoo physics. All right. Yeah, thanks enough. I hate it here.